So good afternoon everyone. So in this video we are going to discuss about standard test inputs in the module 3. Okay. So first what we are going to discuss about in the standard test inputs. So in evaluating the performance of a system, it is necessary to assume basic standard test input signals. Okay, so by assuming these standard test signals, not only the mathematical analysis of the system is made easy, but also this input signal response allows to predict the system's performance to other more complex input. So for the ease of time domain analysis, following standard signals are used over here. Okay, so in the test signals, the analysis point of view, signals which are most commonly referenced inputs are defined as a standard test input. So in another way we are going to mention as a test signal. So the commonly used test signals are, that is the step input signal, ramp input signals, parabolic input signals, and impulse input signals. A step, first we are going to discuss about step input signal. Okay, so the step input is a standard test input whose values changes from one position to another position if in zero time. Okay, so it is also known as position input. The other name of the step input is called it as position input. So here what is the point you should have to remember over here? The value changes from one position to another position with zero time. Okay, that is step input signal. So here one more definition: it is a sudden application of the input at a specified time, as usual in the figure or instant any as change in the reference input over there. So here the figure is shown over here. So the time it will be shows over here. Okay, so if you see the this one, uh, see the conditions. Okay, so that figure we will discuss later. So in this one example is the if the input is an angular position of a mechanical shaft, a step input represents the sudden rotation of the shaft. Okay, then switching on a constant voltage in electric circuit, and another one is the sudden opening or closing a valve, normal valve. Okay, these are all the examples. In the step input signal, what happens over here, the step input represents the instantaneous changes over here. Okay, see over here the arrow mark, it will be goes straight on. Okay, so with respect to time. Okay, so a step is signal whose value changes, okay, from one value, okay, to another level a in a zero time, one value to another value in a zero time. So in the Laplace transform of R of s is equal to a by s, mathematical R of t is equal to u of t, equal to 1 for t greater than or equal to 0 and 0 for t less than 0. Then comes into the next input signal, ramp input signal. Ramp input in the ramp input signal. Okay, so ramp input is the standard input signal which changes with the time linearly. Okay, it will be changes with the time linearly, and it is also known as velocity input. Previously we have discussed about the step input is the position input, and also this one will be the velocity input. See, if the time is means the distance into the distance into time is called this one. Okay, so that's what it is also called as velocity input. So here the graphical representation of the single, it will be showing over here. It will be gradually increases over here. Okay, so normally for in this one we are giving the example for the ramp input signal is the altitude of the control of missile. Okay, the ramp is a signal which starts from 0 and increases linearly with time. Okay, so linearly with time, mathematical r of t is equal to at of for t greater than or equal to 0, or 0 for t less than or equal to 0. Okay, so a is equal to 1, it is called it as unit ramp input. Okay, this is about ramp input. Then comes into the next thing, parabolic input signal. Okay, a parabolic input is a standard input signal in which instantaneous value of parabolic signal, it varies as square of the time from initial value of 0 at time t is equal to 0. Okay, so normally graphically it will be representing over the parabolic input signal. So in another way we can define this one like the input which is 1 degree faster than the ramp type is of input is as shown in the this figure. It is an integral of ramp. So this parabolic input signal is also known as acceleration input. Acceleration input. Okay. So here A is given for R of t is equal to at square by u of t. So it will be graphically representing over like this the signal parabolic input signal over here. So R of t is equal to at square by 2 for t greater than or equal to 0, 0 for t less than or equal to 0. Here in Laplace transform R of s is equal to a by s cube. Okay, then comes into the next thing, impulse input. So a impulse input, a standard input signal whose value is 0, whose value is 0 everywhere except t is equal to 0. It is generally called as del function. So normally first one step input is called it as position input, and ramp input is called it as velocity input, and another parabolic input is called it as acceleration input, and this impulse input is also called as the del function. Okay, so here in another way it is the input applied instantaneously of very high amplitude is shown in figure. Okay, see over here it is very high amplitude, and t is equal to applied momentarily. So in this pulse whose magnitude infinite while its width tends to 0, area of impulse its magnitude. If area is unity, it is called as unit impulse denoted as a t. Okay, so mathematically it can be represent r of t is equal to a for t is equal to 0 and 0 for t not equal to 0. Okay, and lt from r of s is equal to 1 if ia is equal to 1. Okay, so these are all the input signals we are going to be discussed on this class. Okay, so this will be comes under the which one standard test inputs. Okay, so thank you. The remaining things we're going to discuss on the coming classes. So that uh, step input is the position input, and ramp input is the velocity input because it will be gradually increases with respect to time, and parabolic input is double time of the ramp input, so this will be acceleration input, and this impulse input we can call it as del function. Okay, so these are all the points you should remember. The remaining things we'll see in the next class. Thank you.